Now, if you're following around in the handout, we are now on page 7 because the other two examples with the blocks and the two head-on billiard balls require using energy with them. So we will come back to those after we cover energy in the next unit. Okay. So now let's look at two-dimensional motion. This is ball A, ball B, that's ball A. Kind of got messed up when I started redrawing it. So two-dimensional motion is doing the exact same thing that we've done with projectile motion and with forces. All this says is that I need to take my momentum into my X and Y pieces. So let's see. If I kind of go like this, I'm going to have, if I go that away and up is positive, then I can say, okay, in the X direction, what do I have? Well, initially, the only thing I have moving, this thing here is stationary. This is page 7 of your handout. So this one's stationary, this one's moving. So I have mass A times velocity A, and that's it for the initial picture. And what does that equal? Well, in the end, let's see, I have a velocity coming down like this. So I can kind of think of this as there's my X component of both of those velocities. So I have an X component going out for the B and an X component going out for the A. So that will be mass A, and they're both going in the positive direction. So mass A, VA prime, times, that's touching that angle, cosine of 45. Plus, and again, it's still going in the positive direction, plus mass B, velocity B, times also cosine, because that's also touching that same angle, cosine of 45. In the Y, well, gosh, I have nothing in the Y. This thing is completely on axes. So I have 0 equals, now what's happening over here? I have mass A, V prime A, times, well, this piece going up would be in the positive direction as I've defined it. So positive sine of 45. Let's see, this one is going down. I've defined down as negative. So minus mass B, VB prime, sine of 45. So that says that mass A, V prime A, sine 45 equals mass B, V prime B, sine 45. Now I'm not putting any numbers in there because if you know anything about sine and cosine, you realize that this thing is going to be equal to this thing, which can lead you to some confusing conclusions. So don't use 45 and don't use 30 or 60 as your test angles when you're trying to figure things out. But what this does demonstrate nicely is we're doing the exact same thing we've done before. Nothing has changed. We're just looking at our beginning picture and comparing it to our end picture, and we're going to do the same thing in the Y. Here, it's going to be really important to be disciplined, to be comfortable putting 0. If something isn't moving, it's okay to have 0 to begin with and have some momentum in the end. Okay, so the other thing I want to emphasize here before I end this particular video is that all of our action here is in the X. So what had better happen is that if I'm going at an angle suddenly, that I have to have equal and opposite components in the Y here. I had no momentum in the Y. That means my net momentum in the Y must be 0, which is what we defined here. But this little thing here will help you when you're not told which way the other one goes. If I'm starting off in a straight line, if one goes up, then I know the other one must go down. Otherwise, I won't have conservation here.